So we're nearing the end, Math 20-1, of our skill building and solving rational equations. So when we look at our learner outcomes for this one, we are moving towards solving problems that involve rational equations and limited to numerators and denominators are monomials and binomials. So what is it that we need to do in these next two sections? This is going to be two sections. So part one, we are going to consider determining non-permissive values, and we're going to talk about determining the solution to a rational equation algebraically. So that's part one, solving rational equations. And the other part that's part of your skills is explaining why a value obtained and solving may not be the solution to the equation. So that idea of extraneous roots. In part B, we're actually going to take our skills and actually solve some real problems. Okay. The explaining the process used is tricky, and that's where we get into standard of excellence. And if you can do that, you really know your business, right? So carrying on, first thing that we need to consider is what's the difference between an expression and an equation? What does an expression look like? Well, an expression might be something as simple as x, whereas an equation might be x equals 5. An expression might be 1 over x. An equation might be 1 over x equals 5. That is a pretty cool expression, but this would be an even cooler equation. What is the difference between an equation and a function? Sorry, an equation and an expression. I want you to ponder that, and we're going to discuss that in class tomorrow because that's a key thing. It's amazing. And the other question here is, what do you do with it? What can I do with an equation versus an expression? So those are my two questions to you as you complete this, and that's understanding versus just knowing stuff. There's a difference between these two things and what we do and what we're allowed to do. And I want to make sure you're 100% clear, okay? So which one can you simplify and which one can you solve? And what do those words mean? We'll talk more tomorrow, okay? When do you use a lowest common denominator, and what's that used for? We know what it is, and we played with fractions. So when do you use a lowest common denominator? Well, we don't have anything to do. I mean, that is what it is. I don't need a lowest common denominator there. I'm not doing anything. What about this? Do I need a lowest common denominator there? I'm multiplying. What do I have to do with that? I don't need a common denominator there. I wonder if you could tutor me and explain why. I need you to think about this as well. Why? Why don't we need a lowest common denominator there? We say no. Do you know why? Could you explain it? That's the standard of excellence. What about this? Do I need a common denominator now? Do I? I guess not. How about this? Do I need a common denominator now? And if so, why? Or if not, why? Well, apparently we do. What about this? Oopsie. What about this? Do I need a common denominator now? Can I accomplish subtraction without a common denominator? I think we do need that. I wonder why. What do you do with the lowest common denominator? What's the purpose of it? Okay, so we're kind of refreshing the business we've done, but that's really the key. When you discuss with your group tomorrow, when we get together, I want us to have meaningful answers to questions like this. If we do, we'll never forget. If we just memorize stuff, we're probably going to screw it up. A rational equation, when we think about what it is, obviously has an equal sign in it. And we have fractions that, we have fractions that contain at least one rational expression. So we've got polynomials there, right? So those are all rational equations. What do we do to solve them? Well, here's the recipe. So you need to write it down because I think I left gaps for you so that you actually had to do some work. So I need you to complete the following. And what we'll do, you can pause, and what we'll do now is we'll start using it. Well, how does that procedure actually work? Um, this is a key step. This step right here, there's a difference between what we say here in an expression versus what we're doing now in an equation. And I really need you to see the difference. People that don't see the difference here don't get it. We are not making, that's where this guy, this guy's sweating. We are not making equivalent fractions. Equivalent fractions. We're not doing that. We're not making the denominator common. We are using the common denominator to blow up all the denominators. That's the difference with equations. And hopefully that'll be really, really clear as we go through this. It's different than expressions, and it's a lot easier to work with, okay? Well, we'll see. So first off, you're given an equation like this, and you say, I need to solve that. Why does this look different than equations that we've done in the past in grade 9? So let's just look at, well, what would we do with an equation like, let's say I was given, I don't know, let's say I was given 3 times x plus 2 is equal to 4 times x plus 1. And you might have been given that in grade 9. And what would you do? Well, you'd distribute, and you'd get rid of the brackets, and you'd have 3x plus 6 is equal to 4x plus 4. You'd collect all your x's to one side, so you might have 4x minus 3x is equal to 6 minus 4, numbers to one side, variables to the other, and x equals 2. And that was easy. Why was that so easy? Because you had no fractions. So the rule we're going to have, I'm going to erase this grade 9 stuff. The rule we're going to have here is whenever you see fractions, you are going to clear the fractions by blowing them up. And I can blow up fractions because I now have an equation. So my lowest common denominator here is, well, first off, my domain, my non-principal values are minus 2. But when I look at this equation, what's my lowest common denominator? Well, clearly, my lowest common denominator, do I need the lowest common denominator? I do. My lowest common denominator is x plus 2 and x minus 5. Do you need it? Yes. What are you going to do with it? Blow up the denominators. So you're not using the common denominator to make them the same. You're doing this. You're taking that common denominator and you're multiplying both sides by that. Why are you doing that? Because now, notice that I'm not multiplying top and bottom. I'm not making an equivalent fraction. I'm actually multiplying it by this over 1, right? So what it allows me to do is I'm just multiplying the top by x plus 2 and x minus 5. So what can I do? Boom, my denominators are gone. What about on this side? Boom, x plus 2 is gone. Why is that such a good thing? It's such a good thing because now you have a grade 9 equation. You are left with 7 times x minus 5 is equal to 6 times x plus 2. Oh my goodness, what did we do? We used our lowest common denominator to blow up the denominators. We multiply each term by the lowest common denominator, and now I've got a really simple equation, 7x minus 35 equals 6x plus 12. So that means that I can collect my x's together. 7x minus 6x is equal to 12 plus 35. So that means that x is equal to 47. And that fits within our restrictions, so we shouldn't have any problems with that. We can check, and look up here and see that it works out. Okay, and you can also now, it's going to get a little messy because Mr. K didn't use the PowerPoint. I wanted to do it by hand. You can divide out the common factors, and if you do a check by substitution, you'll see, yay, it does work out. Remember, you check your answer by plugging it back into the original question. All right, so yay, it works out. We have another question. We're supposed to solve this one. How do we solve that one? First thing we better do is factor it, okay? So our step said factor it before you even start. This has got a lot of fractions, Okay, my domain is I can't have negative 2, and I can't have negative 3, and I can't have 2. Cool. Do we need to use a common denominator? Yes, we do. Yes, we do. What are we going to do with it? We blow up. And maybe I'll use a different terminology. Instead of blowing up, we'll be more clear about it. What we're really doing is using the lowest common denominator to clear the denominators. In other words, our first job when we have equations is we don't want rational equations. So I want to get rid of, I don't want to see fractions like this. I don't want them. I want to get rid of them. So I can't just do that. So what I do is I use some math and I say my lowest common denominator is an x plus 2, an x plus 3, and x minus 2. That's what the troll says I need to have. So what do I do with it? I take that lowest common denominator and I multiply every term by it. I multiply this term by an x plus 2, and I think I have this on PowerPoint. I multiply each term by it. So you can see what I've done. I have multiplied each term by that x plus 3, x minus 2, and x plus 2. And you might say, well, what good does that do, right? And if you don't feel like writing an extra step out, I would probably write it right here. Right? I might, instead of writing a whole other step like I've done in PowerPoint, you might just write x plus 2 and x plus 3 and x minus 2 right here, okay? And then you can have your fun now, right? So you wouldn't necessarily have to write the whole other step. But what good does that do? Well, I'm going to use red. What good it does is because you've multiplied the whole equation by your common denominator, it blows up, right? You're not making equivalent fractions, you're blowing up the denominator. That cancels with x minus 2 and x plus 3. This cancels, x plus 2, x minus 2, both of those are gone. This cancels, x plus 3, x plus 2, that one and that one are gone. So what are you left with? Well, you're left with a 4 in x plus 2. Don't forget that subtraction. A minus x plus 3 brackets and 1, and you're left with 2 bracket x minus 2. Wow, that's a lot nicer equation. You solved equations like that in grade 9. So this isn't bad. 4x plus 8 minus x minus 3 is equal to 2x minus 4. That means I've got 3x plus 5 is equal to 2x minus 4. So that means that x is equal to minus 9. That doesn't seem so bad. So remember, our first task is going to be to blow up the denominators by multiplying every term by the lowest common denominator, okay? And if you check by substitution, you'll find out that it does actually work, okay? Nice. Well, obviously we got to become tougher and tougher. So now we've got a question. We follow our procedure again, and our procedure is always, I factor first. All right, I did it. I factored it. We now look at this and we say, I got a rational equation. I do not want to have these denominators. I want to blow them up. So my domain, I multiply each term by the common denominator, which is x plus 3 and x minus 1. Now, one of the things we could do right off the bat is we could do this. We could cancel that term out. But in the end, it's probably not going to help us a whole lot because we still are going to have the same common denominator. So there's might be something you know. So my lowest common denominator is that I multiply every term. So I'm just going to do this all by hand this time. So I multiply every term by x plus 3 and x minus 1. Now, I don't like subtraction, so I'm just going to remind you about what that wise math student one told me. Mr. K, is it okay if I just get rid of the negative by adding the opposite? And I said, sure. So I multiply this term by an x plus 3 and an x minus 1. And I multiply this term by an x plus 3 and an x minus 1. That's handy because the x plus 3 blows up, the x minus 1 blows up, all of this blows up, and what I'm left with is a new equation without fractions. 2 and x minus 1 minus 1 times x plus 3 and equals, well, nothing left there, minus x times x plus 3. So I end up with 2x minus 2 minus x minus 3 is equal to minus x squared plus a minus 3x. I collect my terms together to one side, and I'm going to have, over on this side, I'm going to have x squared. I'm going to have plus 4x, and I'm also going to have minus 5. When I factor that, I get x plus 5, x minus 1, which gives me answers of x equals minus 5 and x equals 1. Now I need to check back to see if I'm violating any of my, I am violating, I'm violating this restriction right there. So clearly this solution is extraneous. My only solution, therefore, is x is only equal to minus 5. So you really do have to watch those restrictions to make sure you're not violating them. And obviously I could go back and I could check to see algebraically whether that answer actually works in this equation. But all right, so now I believe if you look at the next slide, it's your turn, okay? So it's your turn to get her done. So I need you now to complete these three and then pause and come back and see what the answers are, okay? So if you come back, you'll see that the answer should be in the first one, x equals plus or minus 7, x equals, t equals 2, and m equals 5/3 is the answer there. Notice that I've left a couple empty slides before you jump into 7.6. So if you'd like me to show you, you can either just stop now if this worked out great, but if you need some extra help and you'd like me to show you how to do A, B, and C, I'll be doing it on the next slide. So now it's time for you to decide whether you need the extra instruction or whether you're just ready to go. Okay, so you can watch or not depending on whether those answers actually worked out for you. Okay. Okay, so I'll see if I can make sure I make it as clear as possible so your journey through these three. So first thing I do is, yeah, this is a rational equation. My lowest common denominator is an x minus 1 and a 12. So I will multiply each of these by x minus 1 and 12 and x minus 1 and 12. I didn't need to factor because they already were factored. That blows up x minus 1 and it blows up 12. So now I'm left with a really nice equation of 48 is equal to, and I multiply that out, I get x squared minus 1. That means that x squared is equal to 49, so x equals plus or minus 7. And that doesn't conflict with my non-permissible values, so that's why the answer is plus or minus 7. Okay. If I look at the next example, again, my lowest common denominator is equal to 15. I don't have any factoring to do, so I multiply each term by 15. 15, 15, whoa, watch that subtraction. Watch that subtraction, 15. So what you might want to do, well, just be careful, but what one student told me to do was, they told me, Mr. K, is it okay if I do this before I screw it up? And I said, absolutely, you can do that. Just make sure you get the same answer. In the end, I can blow up the 5 with 15 and get 3. I can blow up the 3 with the 15 and get 5. So now, in this new world, I've got 3 times 4t minus 3. I now have addition, because I moved that negative in there, and I've got 5 times minus 4 plus 2t, and that equals 6, so not 16, 15 times 1 is 15. So I get 12t minus 9 plus minus 20 plus 10t is equal to 15. 12t. So I end up with 22t is equal to 44. So that means that t equals 2. And there was no non-permissible value, so all is good. Okay? And lastly, the big one that you're trying on your turn is this. So I don't like to rewrite things, so I could factor this. I'm going to do that in green. So if I factor this, I get m minus 1, m plus 1. Okay, always factor first. Not really much to factor here, so now I think, what's my lowest common denominator? My lowest common denominator is equal to an m minus 1 and an m plus 1. Okay, so I'm just going to change that to blue so we don't confuse the colors. So this is m minus 1 and m plus 1. All I did was, I'm going to scratch that off, so what I did was I rewrote the denominator in factored form. And now I multiply the whole thing by m plus 1 and m minus 1, and m plus 1 and m minus 1, and m plus 1 and m minus 1. And what that allows me to do is, boom, oops, that was supposed to be green. Oh well, now I have to go green like this. Boom, all the denominator blown up. In this one, just the m minus 1 is blown up. In this one, just the m plus 1. So your new equation without denominators is 10 plus m plus 1 times 2m minus 5 is equal to 2m plus 5 and m minus 1. 10, and if I multiply this out, plus 2m squared, 2m squared minus 5m plus 2m minus 5 is equal to 2m squared minus 2m plus 5m minus 5. When we bring that all together, let's see what we get. The 2m squareds we can blow up because they're the same. The minus 5 we can blow up. That's the same on both sides. So what are we going to have? If I bring all the if I bring everything to one side, it appears I've got, well, let's simplify this. So I've got 10 and minus 3m on this side, and on this side I've got minus 2m and, whoopsie, minus 2m and 5m is 3m. So I really get 6m is equal to 10. So that means m equals 10 over 6. Oops, so that can be simplified. So that's going to be 5 over 3. And that doesn't conflict with my non-permissible value, so all is good. Okay, so we will see you as you work through your formative in class tomorrow.